Okay, welcome back to the last talk of today. And yeah, welcome.
Thank you. Hi, everyone. Thank you for coming to my talk. Can you hear me okay? I think yes, right? Yeah, cool. All right, so I'm going to talk about Packetbeat, Elasticsearch, and Kibana. I think Elasticsearch and Kibana you all know, I think. But I'm curious, who here has heard of Packetbeat before this conference? Oh, wow, quite a few hands. Great. That's cool. Still, I'm going to do a pretty basic introduction to it, right? Because lots of people don't know it. So what is Packetbeat anyway? There are actually a few ways in which you could describe it. The tagline we have on our website is open source application monitoring, which is quite generic, right? I mean, it's clearly open source, and it's something about application monitoring. But that sort of just sets the scene of what it is. So digging a bit deeper, the reason we even started the Packetbeat project was that we wanted to do something that makes it easier to monitor and troubleshoot distributed applications. By distributed applications, I actually mean almost all applications, because almost all applications today are somehow distributed, right? You have at least application server and a web server and a database server. But I also mean things like microservices in microservice architecture, where you have lots of small components interacting with each other, and at some point it becomes difficult to troubleshoot when something goes wrong in production. Right, and we thought a good way to start this attempt into making a better troubleshooting product for distributed application is to look at the communication between these components, right? Because if it's a distributed system, automatically you have communication between these components, and looking into this communication will reveal interesting things. So another way to explain what Packetbeat is like distributed Wireshark with a lot more analytics features, and we're going to see some of those. And then also we have features like we can give you latency repartitions and response time analysis, and can tell you which transactions break and how many transactions are in total. So there are lots of these features that are usually considered in the application performance management area, so to say. All right, and my favorite way of explaining what Packetbeat is by explaining how it works. So I already indicated maybe a little bit also from the name that it works by capturing the traffic between your servers. And it follows the TCP streams and decodes application layer protocols. So things like HTTP, MySQL, PostgreSQL, Redis, and Thrift RPC. These are the ones we have so far. And it looks for what seems to be a request, for example, an HTTP request. And then in the same TCP connection, it waits for the response, right? So it can capture things like response time, the URLs, response codes, and things like this, right? All right, I'm going to switch to a quick demo now, just of the command line stuff. All right, so the way it works is that you install an agent. That's one possibility. You can install an agent, and we provide the Debian and RPM packages. It's also, the agent is written in Go, so it's actually quite easy to deploy, and it doesn't consume that much memory, at least compared to if it would be written in Java and so on. So that's one possibility. Another possibility is to use mirror ports or tab devices if you are on premise, and this brings you some advantages. I mean, you don't have to install an agent, so that's pretty good. Okay, so normally it runs in a daemon mode, like you have it here. It has a configuration file. I'm going to open it to quickly open it. Do you see this good enough? Okay. So the bottom side is more interesting. You can configure on which interfaces to listen, so where to capture the packets from. You can just use any. you can set some environmental variables, like the agent name, the server on which it is. Some things it can also deduce by itself. And you can apply tags, right? So I just put here that let's imagine this server is part of a particular logical service that you might have, and that's actually a Vagrant server. And then you just need to define the protocols that you're interested in. So I'm interested in HTTP on all these ports, and in PostgreSQL on this standard port. And there are some options you can set for each protocol. We'll see that later. For now, this is kind of the default configuration. And let me stop it from background so that I can start it in foreground and with a bit of debugging. And now I will just create a sample request and response, if the Wi-Fi helps. I think there will be actually 2 requests here, because it first gets a 302 redirect, and then the actual Google page, whatever. And you can see that immediately it printed here a JSON object for each of these request-reply pairs with what's going on. And it sees that it's a GET request on this path, and the response code was 302, let's say. The phrase is also here. And then we also captured some measurements, like the response time. It's here. And then we also have some things about the environment in which we sold this transaction, right? So, like, for example, the IP address is involved, the ports, and the tags that I set in the configuration file. So, like this service and Vagrant. All right, and of course you could easily get this also from the logs. That's pretty obvious. But we can do it for other protocols as well, so not necessarily for HTTP. And we'll see later that in some cases it's more convenient to use the logs. In other cases, it might be more convenient to use packet data. So let's also create a few transactions with Postgres. So I'm just gonna start the client here. Okay, this works. And do a select, for example, like this. And you can see on the right that it creates requests every time I do something. It's actually interesting that even before I pressed enter, I pressed tab a few times, and in order for that autocomplete to work, it queried the server, right? So we can see here, this is the final select that I did. And this was probably from a tab command that I pressed. So you can see that you can capture this way things that you would maybe not expect to. Let's also create an error. So let me drop a table that doesn't exist. Right, it doesn't exist. So you can see here that we recognize that it's an error, status error. And we have some information in the response packet from PostgreSQL about what's wrong, right? So, yeah, that table doesn't exist. And I have to use chance to use my favorite Postgres command, which is sleep, and it sleeps for a while. And you can see it here. The response time is 3 seconds and 3 milliseconds, a bit longer. All right. Are there any questions so far? All right, then we can move on with the slides a bit. All right, now imagine you have these agents installed in all your infrastructure, so on all relevant servers. So they capture everything that's going on in your network. And they all generate these JSON objects, which you can imagine can become quite a lot of data. And of course, the next question is, what do we do with this large amount of data? I would even dare to call it big data. And yeah, the traditional way that maybe I would have done a year or two ago would be to to think, okay, what metrics do we need to extract from these JSON objects? Let's say I'm thinking about response time percentiles, or how many requests are per server, and so on. What are the top 10 hosts? Things like this. I will have to think about beforehand about all the things that I want to extract from the data, and then write some code to actually implement these metrics, right? And then I will need to store them, the metrics, in a time series database probably. So I don't know, like in Graphite or InfluxDB or some other. But because we're interested in troubleshooting, we also want to store the transactions, the actual transactions, what's going on, so that then when you see a graph, you can actually drill down into what's wrong. So for that, you also would need to store the transaction, and you would do that, I don't know, in MySQL, PostgreSQL, whatever. The problem, I already said, this also from the implementation point of view, this makes drilling down difficult, right? You will need to somehow mark into the transactions what metrics they have associated, so then you can implement this drill down. And then features like top 10 methods with errors are difficult to implement. So, I mean, you can do it, but it's pretty hard to maintain. And I know this pretty well because I did this at a previous company where we did a monitoring product for voice over IP networks, and it was this pretty crazy multi-threaded C application. It was very fast, but it got pretty difficult to maintain over time. And for each new feature, we needed to add more code, and things just got out of hand a little bit. Right, so the newer way, let's say, or our solution to this is to use some of the good open source projects that already exist in this area of analytics. And the one that we chose is Elasticsearch, or the ELK stack, so with Logstash and Kibana. And the way it works is that the Packetbeat agents, which you have installed on your application servers, will insert those JSON objects into Elasticsearch. The middle part here with Redis and Logstash is actually optional. You could configure the agents to write directly in Elasticsearch if you want. Yeah, this is the way, the better way, let's say, because then you get a bit of buffering there in case Elasticsearch is busy or whatever. And you also have the opportunity to use Logstash to modify the data. If you need to add a tag, if you need to rename a field, whatever, you have the opportunity to do that with Logstash. And then you have the Kibana web interface. Right, why did we choose to use ELK? Because it's already proven to scale and perform well with logs. There are many users of this stack. And our use case is in many ways similar with the logs case, actually, right? I mean, logs are also usually they get into a JSON object and they get inserted into the database and so on. And the thing that attracted us to this solution is that the flow is simple, right? You have the agents, they create data, you have optionally Logstash to transport it, you have Elasticsearch to index it, and then Kibana to visualize, right? It's a very simple flow. And when you're doing a monitoring product, this is quite an important feature, especially if it's open source and you want people to adopt it. It needs to be easy to understand and easy to follow what's going on for when things don't work. You want to quickly check, wait, is it really not working, or is it just the monitoring system reporting things weirdly? So then you need to have something easy to understand to see quickly what's wrong. And then you don't have to pre-create the metrics, right? So especially in troubleshooting, it's important that you can explore the data, right? You can start from whatever dashboard you have and then choose a different filter and so on, so that you can get down to what's wrong, right? Without having to add code to create new metrics. okay, the ad hoc troubleshooting analytics with Kibana. The Kibana is a nice web interface for doing this. I will go through a demo a bit later. Drilling down to the problematic transaction is very easy because every visualization of a graph, every metric, is based on the actual data. So it's very easy to just use the same filter or the same search to get the actual data, and that's very useful for troubleshooting. And things like top-end features are also trivial by using Elasticsearch aggregations. So it's just an Elasticsearch feature which you can use for free. Right. And then it's easy to slice based on different dimension. What I mean by that is, let's say you have the top n hosts, but you also want to see the top n URLs or the top n services, or these are different dimensions, right? And you can easily slice the data by one or the other, and about new ones, whatever. Okay, we can switch to the demo again. So I have Kibana running here, and if I refresh, I should see the request that I just did, right? So in reversing order, there was the sleep command, which took 3 seconds. The error here, you can see that the status is error, and then what did I do? Can even see that was one that actually took quite long, which is interesting. And these are the HTTP requests that I did to google.com, and the rest were test runs. Let me now switch to some data I created yesterday to show other things. Right, so here you can see again what protocols we support. So PostgreSQL, HTTP. Okay, let me zoom in to here. We also support Redis and Thrift RPC, which is interesting also for this microservices case. You can have microservices talking Thrift RPC between them, and then we can show those, right? And you can search, of course. You can do structured search. So let's say I search for type MySQL. And then usually what I would be interested in is to look for error transactions, right? So these are all okay, generally speaking. But I can set, okay, let's set a filter by MySQL as well. And I can do this contextually here. I can set status is not okay. And now I have them here. This I don't need, right? So the filters are set here. And now I can see only the errors. And what's interesting here is that the way we do it with Packetbeat, and this is a bit different from logs, is that we unify the format from all these protocols, right? So the status is not just MySQL status, it's the status for any type of transaction. So when I filter for error, like let's disable this MySQL one, I get really all errors regardless of the protocols. So you see there are Thrift and so on. Okay, and I can also see, you see the chart here updates every time I change something. So there are like 200 errors per minute, generally speaking. And if I enable the MySQL filter, then there are only like around 20 or something like this. So you can quickly get an idea of the size of the problem, let's say. Yeah, in this case, we notice that most of them has this bug 66 in them, like a keyword. So I can search for that, just to be sure if these are really all the errors that I have. So yeah, it's a search engine after all, Elasticsearch. So you can search by any field. You can also search, by the way, by an IP address. So I can do like I don't know what I used here, like this, right? Oops. Okay, maybe I didn't use that one. All right. So yeah, now it will search the IP in all fields that are relevant. And Kibana 4 is quite nice that it also highlights, right? It highlights the matches, so you can quickly see where it saw it. It will also work if it sees it in the message. All right. Yeah. Now let's go a little bit to the dashboards. No, there was something else. Back here. Yeah, go ahead, please.
Do you also support encrypted protocols? I mean, like if I'm using TLS for Postgres, for example.
Okay, so the question is if we support encrypted protocols. No, that's a disadvantage. There are some potential solutions for that. One of them that some commercial competitors, let's say, do is that you give them the certificates, and they will decrypt the data on the fly. So that would be a possibility. I'm not that much of a fan of it because I don't know if this is really a nice thing to do. Another possibility that we would prefer is to have a proxy. Like you usually want this when you want to monitor third parties, right? So you use an API from, I don't know, let's say from Twitter, and you want to monitor that, right? And then you could use a Twitter that essentially logs the transactions, but it will log them with the payloads as well. So like you would have like you would have from Packetbeat. So this would be the solutions that we have. But yeah, as I said, there are cases where it's more convenient to just use the logs, right? Like for example, if you have an Nginx server that's just serves statics files, and you have the logs from it, it's just more convenient to use those than to use wire data, right? But there are also cases where it's more convenient to use wire data. I will go through the advantages and disadvantages later on in the talk, actually. Yeah, so something else I wanted to say, to show here, is that you can also filter for things not containing something, search for things not containing something. And why doesn't this work? Okay, this doesn't contain, but I thought I have the filters here. Right, so it works exactly like in Google, right? You say minus something, and it will search for everything that doesn't contain those keywords. Yeah, and another thing to mention here in the configuration file is that you can enable more data. So by default, we don't store that much data because of privacy concerns. So you wouldn't want to accidentally, put in I don't know, bank account data or so on into Elasticsearch. So by default, we leave these send requests and send response to false, but you can switch them to true, and then we will record the whole payload. Let's do a quick example of that one. It was for HTTP, so I have to do this again. And yeah, you see there's more here. Now you have all the headers. You still don't have the body. It's a different option where you can select which bodies you want to save by content type. So you can say, for example, that you want to store everything that's JSON. But you don't want to save like pictures and so on, right? It depends what makes sense in your use case. Okay, and now let's get to what I think it's more interesting, or at least nicer to show. The dashboards that we have. So Packetbeat, the project, sort of comes with a few predefined Kibana dashboards. Just to make it easier for you to start, right? So it does common visualizations that you would typically expect from an APM type of product. So you have here, this is the thrift dashboard. Let me go to the default one. Loading. All right. So you have the total amount of HTTP transactions and the total amount of database transaction, right? Postgres and SQL. The same for cache, for Redis, and RPC. We could also do here the sum of the response times. So then you could see, like in a single visualization, where the time is mostly spent, like if it's spent in the application layer or if it's spent in the database layer and so on. Actually, I will show this later if we have time. Then we have response times percentiles. This is also an Elasticsearch aggregation, which we make use of. You can tell it to okay, on this set of measurements, show me the percentiles, right? So the 75 percentile or the 99 percentile. Which I think you all know what it means. It means that 99% of the transactions are faster than this. Right, and then the error rate, right? So what percentage of transactions are errors? The evolution of errors. The latency diagram. This is also interesting. So you can get here you can see that, well, most of the transactions are below 20 milliseconds, right? Error codes and so on. And now let me switch to the Thrift RPC Performance one. This is what I wanted to also show. Here we have a few of these example top 10 widgets or visualizations, right? So here they are the top 10 or top 5 RPC methods used in the system, right? So you have ping, zip, calculate, and so on. And you can also have the top 10 or the top whatever that have errors, right? So by the number of errors, top 10 by the number of errors. So it's quickly, you get a quick overview of what's going wrong. And here you have the slowest one, right, by average response time. So you can also do that. And you can do this also for, like, for example, for MySQL, for PostgreSQL, things like this. Right, so this is the MySQL one. Okay, another thing that I wanted to show, so all this was Kibana 4. If you go, for example, to our demo site on packetbeat.com, you'll see that we still have Kibana 3 there. And the reason is that we added this widget to Kibana 3. We call it a forced layout. But I think it's a good widget because it shows you exactly the communication, right? So you can see here how the traffic is coming, right? So you have this coming from unknown IP addresses going to NGINX servers and from NGINX to other application server. And here it's configured to use the server names, but you could also do it by IP addresses, by logical service, by whatever field you want, right? The widget is pretty flexible. And you have here also the Vagrant stuff, which is probably due to the test that I just did, probably. Right, and I was saying that this we only have in Kibana 3 for now, unfortunately. We're looking for the best way to implement this in Kibana 4 as well. So Kibana 4 will support plugins, which means that people like us can create new widgets for it, but the plugin interface is not yet ready, right? So it's a big warning when you open it in the README file in the GitHub repo saying don't use this yet because it's not stable. Okay, so what we did then was to work on our own new interface, but I'll talk about that later. Now, because we're pretty good with the time, Let's create a visualization, a new visualization, just to show you how that works. And the one that I want to create is, I don't know if you know New Relic. One of the first things that you see when you log in is this, what I said earlier, the amount of time spent in each layer of your application, let's say. So let's try to do that. I'll just pick the default search here. And the aggregation that I will use is the sum of response times, right? And I can apply that. Okay, what did I do wrong? Am I good here? Okay, refreshing probably doesn't help now. And what if I do sum of something else? Count. Okay, let me check if the filter is correct. Maybe this applies somehow. Okay, I'll try once more. If it doesn't work. Let's do a new search. I think what I did wrong was that I just tried to do it too early, and it didn't have all the information that it needs. So I also need to set what we want to show on the x-axis, or obviously. So I want the time on the x-axis. So in Kibana, that means you want the date histogram by field timestamp, right? So now we have the total amount of time spent in your application. The unit for that is not that important. It's in milliseconds, but it's just the total amount, so it's not that relevant. But then what you can do is add a sub-aggregation, and here we will split area, so we create one of these stack charts. And the sub-aggregation will do terms, because I want to separate this by the type of the transaction, like this. And if I apply it now you have the, yeah, it looks quite nice. You have the time spent in each layer of your application. That's the idea. All right, any questions so far? All right. Continuing with the presentation then. I'll skip this because it's just what I already showed you. So let's talk now about the pros and cons of wired data versus other ways of getting data about your transactions. So the things that happens in your systems. So one important advantage is that it captures things that you wouldn't expect. For most other things, you need to do something to get this data, right? Like for logs, you need to, well, at least enable them. In your application, you need to write the right logs, and so on, right? But with wired data, if something happens and it's in a protocol that we can understand, then it will for sure show up, right? Another thing is that you don't need to do any kind of code changes, and generally don't touch the application at all, right? So with tools like New Relic or AppDynamics, you have to run an agent in your JVM, for example. But with wired data, we're completely passive, right? This means if you troubleshoot a system that's monitored by Packetbeat or whatever wired data system, you need only minimal knowledge about what the application is doing, right? You don't. In other tools, you need to know more about the internals of application. But here, because the protocols are kind of universal, you can understand and use it without that much knowledge. There's no latency overhead because we work on a copy of the traffic. So yeah, that's important. With logs, the overhead is minimal, so probably you wouldn't care about that too much. But with APM tools, the latency overhead can be significant in some cases, so you have to be careful there. And then if you use, like if you are on-premise, so you don't use the agent, but you use tap points or mirror ports to extract the traffic from the network, then you don't need any sort of CPU or memory consumption on your application server. So that's extremely passive, right? You could have a system, you could have a fully proprietary system like an appliance that speaks HTTP, and you would still be able to monitor it this way, right, and measure its performance and so on. But there are some disadvantages as well. First, there can be like tons of data. I'll talk a bit later about how we can address this. I'm saying it can be a lot of data because imagine you have a Redis server. It does 100,000 requests per second, only like a single normal instance of Redis. And we will need to store all of those in Elasticsearch. You can imagine this gets to a large number quite quickly. Compared to log processing, it does consume somehow more CPU because we need to do sniffing, which it doesn't come for free because we need to copy the packets from the kernel, and we need to parse the protocols, right? So it's a bit more CPU usage. There are privacy concerns, as I said. It could be that you log things that you didn't intend to. We also have a plan about how to improve that. Doesn't work with encrypted protocols. This was already a question. We've discussed it. And doesn't work for your own protocols, right? So if you use if you decide to develop your own protocol, Packetbeat cannot understand it unless you contribute the parsing code to it. Right, so these were the pros and cons. Let me know if you can think of others, pros or cons, or if you have any other questions overall. No, okay, we go on. So I wanted to go a bit into what our future plans. So first of all, more protocols. The ones available today are HTTP, MySQL, PostgreSQL, Redis, and Thrift RPC, and we want to work like soon on the ones on the right. So DNS and Memcache will probably be quite easy to do. There are lots of people requesting all sorts of database protocols like MongoDB, RefingDB, Oracle, Microsoft SQL. These are generally more complex, right? So it will probably take us more time. XML RPC, JSON RPC are also useful, again, if you have some sort of SOA or whatever. And yeah, if you have any suggestions, let me know. We could do MQTT, for example. Right, and we are also working on creating a contributors guide for adding new protocols. It's not ready yet, but hopefully this will make it easy enough to add your support for whatever things you need yourself. All right, another thing, this relates with the problem that wire data can generate really large amounts of objects. The way you think a pretty good solution is to have sampling, which means that we would only store parts of it, and we will record what the sampling rate is for each transactions that we store. So this will balance a bit the troubleshooting convenience with the hardware requirements, right? So how much disk space you want to give to Elasticsearch, essentially. Of course, if you have all the transactions, then troubleshooting is a pleasure because you can find whatever went wrong, whenever went wrong. But if that's not economically feasible, then you can use sampling. And the way we want to do it is to have this flexible, so you could do it, for example, different per protocol. So you could say that, hey, I want all the database requests, but the Redis requests, which are really a lot of them, only sample them, or sample all Redis GET requests, but write all the Redis requests that are actually modifying the data, right? That could also be useful. By status code as well, like store all the errors and only sample all the successes. By response time, so we could guarantee that we store all transactions that are taking longer than usual, or things like this. Right. The next thing is string obfuscation. This is to address the privacy concerns. So because we parse these things, we can also parse the SQL queries, for example. And wherever we find a string, we would replace it with something like this. Like in the first example, two-door is replaced with S8 because it's a string, and it has 5 letters, and the next power of 2 is 8, right? So you would use the next power of 8 to have S and the number, and the same with the ID. I did a mistake there. It should be N4 because it should also use the next power of 2. The advantage of this is not only that it helps with making sure you don't store anything that you don't want to store, but also when you have top-end charts, they would be automatically better, right? Because if imagine you have a select query that's always the same, but differs in one parameter, then in the top query this will only show up as 1, right? So it will make for a better widget for that. This idea, by the way, is taken from this book, the Mature Optimization Handbook by Carlos Bueno. It's a really good book. From Carlos Bueno is a Facebook engineer, and it describes a system that's actually quite similar with Packetbeat in some ways. So I do recommend this book, and it's also free. So you can just download it as an ebook if you just Google it. I totally recommend to read that. All right, and I almost introduced this too early. So Bonito is it's a UI we're working on, but it's not yet released. It's not yet ready. What we want it to be is complementary to Kibana. That means it will be an interface that's more focused on application performance, and you can still use the very generic Kibana interface to create your own visualizations and so on. Hopefully, at some point, Bonito will become a Kibana 4 plugin, just to make it very easy to use for you and to switch between them. For now, we're developing as its own project. I can show you that as well because we have time. I just need to generate a bit of data. Right, and let's do this. Okay, so the idea here in this view, this is also inspired by somewhere. If you know the Hystrix dashboard from Netflix, they also have this green planets, we call them, which gives you the relative size. So the idea here is to have a quick way of comparing different dimensions, right? So a dimension, as I said, it could be a logical service, or it could be the hosts, or it could be URLs, methods, whatever, right? And the point is that you can easily put them all on the same page, and this is, from the UI point of view, is designed to scale to large number of things. And for each of them, we show some key metrics, like the total volume, some sub-metric, like how many hosts there are in this service, for example, the response time percentiles, error rates, and things like this. And you can reorder this by, for example, by volume, and now all the big ones are at the beginning, alphabetically by a particular response time, and so on. All right. Yeah, and it will also have, it will make it easy then to drill down to a particular dashboard for it, and then to the actual transactions. But this is not yet ready, actually. I just wanted to give you a preview. All right, anything else? Okay, a little bit about how to deploy Packetbeat if you decide you want to give it a try. So we have a pretty easy to follow getting started guide on our website, which will walk you through installing Packetbeat and Elasticsearch and Kibana manually. But we also have what we call Packetbeat Deploy, which is an Ansible project, which makes this automated. Yeah, and if you already use Ansible in your environment, you could probably easily adopt this. Otherwise, you could still use Packetbeat Deploy to set up like a proof of concept and whatever, and then use Puppet or whatever you use to do the real thing. The nice thing about Ansible is that it makes it easy to support like multiple Elasticsearch nodes and different configurations, and you only need to edit these host files to add your hosts, and then you run this command, and it will get everything executed for you automatically. So I think it's a good fit for this kind of projects where you just want to set a quick POC, still spanning on multiple machines. All right, that was deploying, and that's pretty much all from me. So if you want to keep up with the project, you can do that on Twitter, Packetbeat, or you can also follow me if you prefer not following a brand. You can also subscribe to announcement mailing list. It's essentially a newsletter, but don't worry, we won't spam you with marketing stuff. And of course on GitHub. Yep, that was for me. If there are any questions, let me know, please. There we go.
One question regarding new protocols we parsed. The Wireshark project already has tons and tons of parsers for lots of protocols. They understand what's in there, they parse the fields and display them. Wouldn't it be an idea to integrate these parsers already existing? Because with one shop, you would have lots and lots of protocols.
So the question is if we couldn't just use Wireshark decoders to do the parsing, and then we will have all the thousands of protocols that Wireshark supports. So that might actually be an option. The reason we didn't really consider it so far is that it will probably be not fast enough to keep up with the traffic speeds. I mean, if you open a 2 GB file in Wireshark, it will take a little bit until it's loaded. We can be kind of faster than that because we can parse only like the headers that we need, for example, not really every small thing there like the decoders do in Wireshark. And then we have the choice of not parsing everything, right? So if we look at something and say, well, this is indeed an I don't know, MySQL message, but it's not a MySQL message of interest. Let's say it's a heartbeat or something like this. We can just keep those and just look at things that are interesting to us, right? So that's the reason we didn't didn't just use Wireshark plugins. Right. We do, yeah, we don't do that yet, but it would, yeah, we could, yeah, we could have like IP addresses, ports, and things like this. We don't do that today, but I imagine we could. There was a question here.
Almost the same question.
Okay.
Recording just the plain TCP connections with connection length.
Right. So there's another project that's actually also quite similar to Packetbeat in the sense that also uses packet capturing and also stores things in Elasticsearch. It's called Moloch, I think. So Moloch is more on this use case of storing everything and then looking for particular pickup and particular packets. While we are more focused on getting application data, right? So we try to get as fast as possible to the application layer and provide interesting things about the application layer. I think there was also a question in the back. Yeah. Mm-hmm. Right. So most people use it. Right. Okay. So the question was, let me see how I summarize it. So yeah, the question is, there are lots of the things that I showed today. They are cool and so on, but they could also be accomplished in different ways by using logs or by using something else. And how are the current users of the project using it? And it's most of them are using it in systems where they don't have full control of what's going on, right? So they cannot easily modify logs, for example, what logs are written, or yeah, for whatever reasons they were looking for another solution. And they found us, and then it's easy with Packetbeat because they can just install the agent and they get this data. So at least for now, it's a lot about convenience. I think in the future you can also differentiate by different features and so on. Yeah. Okay, I think that was it.
Okay, thanks for the talk.
Thank you very much.